Nice.
Oh, true. Yeah. Just the screen itself. So let's go with it here. Let's see if this will make sense. This is the end of 5.1. I did want to get you guys the generic formula. So let me set up everything.
5.1 like, yeah, what is this?
Uh-huh.
I got through the first problem. I was like, no.
Looked at it.
All right. Let's see. And
ratting on themselves.
Oh, that.
all right. What we have to do is we have to set up this generic formula.
Softest spot.
Which so I'm gonna.
I don't have Calc.
We have like.
Yeah, we started this already. Yeah. I'm gonna just jump to it because we need it here. So I'm gonna list everything that we know so far. So remember, we start off with A, right? And then what we do is we do iterations of it, right? So it's going to be x1, x2, x3. We keep on going all the way to an xi. That's kind of like somewhere in the middle of the group. We good? And then we can get to x of n minus 1. And then we get to x sub n. We good? And then we also note that we're going to make a little formula for the width of these. Good there? Okay, so now the question is this. Instead of starting at 0, what about if we just started somewhere? Some A value and some B value. And we talked about this last time. You talked to me. We were good. This is x sub 0.
It's xi and then x.
So
X of n minus 1.
Okay.
I have some bad news. Val Kilmer has died.
Oh no.
For
Oh,
those of
that's
you
not
that
cool.
don't know random names of pop culture, that was the actor for Iceman and Top Gun. He died yesterday.
Yesterday? Wow.
No, that
Yeah.
was in the movie.
Character in the movie.
No, I swear that dude
No.
died.
No.
Did somebody else die for that movie? No. I'm not crazy.
Also famous for his
You
role
lie.
in Tombstone.
I know what you were talking about.
Yeah, Tombstone as well. Popularity.
Val Kilmer. I'm
Yeah,
not
he knew.
surprised. You're like
He
the
knew.
second oldest person here
What do you mean by that?
after Mr. Hunt.
No, you would.
Your favorite movie is High Noon, dog. Sorry. When you say you listen to Hank Williams, you don't even mean Junior.
Thank you. Yep. Didn't see it. Move it across. Thank you so much. Okay, guys, real quick here. So let's see. All these guys right here. So from x0 or x0 to x1, that would be one width. Is that right? And so the widths we're just going to label as that. So the question is, how do I get to x1? How do I get to x1? It's going to be starting off at A. We're good? And notice it's just going to be adding the width of each one of these guys. We're good? So then if I want to go to x2, all I do is I start off with A still, except I'm just going to double my width each time. And that gets me all the way to x sub 2. And if we want to go to x sub 3, all we got to do is we got to do 3 widths across. Are we good there? Again, totally abstract. We're good? So if I want to go to x sub I want to get to this one right here. I got to start off in A, the beginning value, and I got to get to I iterations, right, of my width. Everybody okay there? And to get to my last one would be A plus n times, right? N times that. Are we good? Okay, so we're just trying to make a generic formula here. So for the right side, go ahead as you guys are writing it down. Go for it.
So like the space in between each thing is changeable. Like the whole.
Yes. Yep.
When we have the function defined.
Yeah, whatever the function is. Now it's a generic function right now.
But we have it defined. We know that f of x equals whatever it equals.
Yeah, it's something if equals something. Yeah.
So we can plug that into the general equation.
Yep. So let's do this here. We're going to do the definition 2 process here. So definition 2 is talking about right angles. So keep up with this here. Let's see if we can kind of put this together. I know it's abstract. So remember how we always took n goes to infinity? Remember that one? X squared. And so now the question is what are we taking to infinity? So we're taking the width each time. Aren't we taking the width each time? But then also, in order to get our height, we have to use our function. So see if this one makes sense. This would be for right endpoints. So for right endpoints, remember we always start off with x sub 1 already, right? And we already have a width. True, true. And then all we do, this is my height right here, whatever our function was x squared, right? But this function is just any kind of function. It's just f of something. And then all we do is we go to f sub 2 or f of x sub 2. And then there's my width again. And I keep on doing this all the way up until I get to that. Okay, so I'm just writing a whole bunch of stuff on the board, but this is stuff making sense here. So my function, it was x, it used to be x squared, right? And we chopped it into 4 pieces, right? So this was like 1/4 here. This was 1/2. We kept on going all the way, got to 1. All right, so this is using right endpoints or the right side of my. So now the question is this. How could I write this in terms of a sum formula? It's going to be the limit as n goes to infinity of the summation of. And let's see, I get my iterations of I starts off with 1. Remember, for my right endpoints, we start off with 1, right? And we go all the way up to what?
N.
We go all the way up to n. And all it is really is just f of x sub I multiplied by the width of each one. Okay, a lot of abstract stuff there, but you tell me, does that make sense there? That is the general equation for using right endpoints.
We defining x1 as the first, as we're defining x sub 1 as x as a to the plus a plus 1 times delta x.
Yep, as we get our iterations.
Okay, yeah.
And we'll do, again, totally abstract, and we'll just jump to actually real numbers here just for a second here, but we got to do this part here. Okay, so real quick here, that was the right endpoints. Can we do something with the left endpoints? Remember how we're always 1 behind, right? On the left endpoints. So let's do this one here. This is, in your book, it's called definition 2. That's called using right endpoints. Definition 3. Now is using the left endpoints. Let's see if this makes sense now. Again, same exact process. N goes to infinity. But where did we start off when we were using the left endpoints?
All right.
We started with the left one, right? And remember when we did x squared, we start off with 0. Is that right? We went this way. So in this case, we go like this. We start off at 0, and then we still have we still have the width. And then we go off to 1, and we still have the width, and we keep on going all the way up to, how much did we go up to when we went to
N minus 1.
n minus 1? Perfecto.
My entire life.
Still multiplied by the width. Okay. Can we put this guy into the generic form?
Wait, how do you define, don't you have to define x to the 0, or x to the 1, or x to the n before we make that formula? Because
Yeah, we'll
not
define
just
them.
x equals 0, it's like in the interval, the first number of x.
Yeah, but we do need the function in order to define it technically. So we'll see how that works in just a bit, because we're gonna have to put numbers to it. But just in generics, it's just the function at that starting interval. Okay, quick form. How about this? This is the left endpoints, and did I write down the formula? We should write down the formula. I might have to erase it a little later on, but let's see.
It's like,
No,
get it.
try it yourself.
Yeah, Santa didn't exist before.
Okay, so definition 4. So real quick here, definition 4 is the most generic form, right? Quick here. So this is interesting, I think. So we were using left points. We were using right points, right endpoints, right? And then remember, what's the other one that we used?
Midpoint.
The middle, the exact middle of stuff.
Definition 4.
And no, definition 4 is going to be even more abstract than that. Okay, so definition 4 says this. If I have a Okay, let's do this one here. Let's area. Let me write this one in. Area is the limit as n goes to infinity of the summation. Oh, cool. So
N minus one and have that.
here's what we do here. We just go like this. We still want to start off with 1. And we want to go up to n.
That's my
Perfect.
I minus.
Yes, This guy's going to be to the xi minus 1
Mm,
in order to get it back down to 0. Okay, the most abstract form that's possible. We use the midpoints, right? But if I'm looking at x squared, don't need to write this down, just gonna with me here, real quick here. The generic form says this. I can chop this up into 4 pieces. True. And I do have a picture of this a little bit later on because, so notice, remember how we chopped it up into 4 pieces and we use the right or the left or the midpoint, right? We use the midpoint right here. The question comes up is, do I have to use any one of them or is it really just notation? And turns out, if I'm getting smaller and smaller and smaller widths of my rectangle, right? I could be anywhere that I want to be inside that rectangle. Are we good? I don't have to be in the middle. I could be like a third of the rectangle. I could be a fifth of the rectangle away. We good? So the middle form, this little part right here does not matter where I'm at. We good? So let's write the form for it and then we'll see.
That's
We'll
what the
see.
stars were?
That's where the stars were. Okay, so we have this little star thing that's over here in the book. And it just means this. It means that it doesn't matter where the function is, as long as it's inside the rectangle, and as long as I get a height sometime somewhere.
This is somewhere in between.
Mm-hmm. And so the form, so any point, whatever, it does not matter. That's that one there. And then here it is. So the limit as x goes to infinity of I from 1 to n of f of x sub I star. Look at that. Never knew there was like a star inside.
really just putting anything in there, huh?
Yes,
They said good work to get a star. You did your best.
You use all the gold stars you've earned.
It's a sum of gold stars.
Some of the gold paper.
So the stars mean,
So it we'll do a quick we'll do a visual in just a second here. But it is any point as long as you are inside the rectangle.
Inside the range of delta x, isn't it? Because there is no defined rectangle. You're defining the rectangle, aren't you?
Yeah, I'm defining the rectangle, but individual rectangles, right? So it doesn't matter where I'm at inside the rectangle. I could be a fourth of the way, right? Inside my rectangle. I could be exactly in the halfway, which is my midpoint. I could always be 3/4 of the way. I could switch them around anytime I like.
So you mean the line segment, anywhere inside the line segment?
Line segment, I guess, yeah.
Because you're defining the rectangle will change its shape, depending on where you are, what line.
Yeah, so individual rectangles, yeah. All right, so how about this one as a visual? See if this makes sense here for the last one. So if we were always using the right-hand side, we would be using this right here. If we're using the left, we would be using this. The asterisk or star just means it doesn't matter where I'm at inside my rectangle. I could choose any height I like inside this little rectangle. I can choose the middle, exact middle. That looks like the exact middle here. That looks like the, what, 3/4 of the rectangle? There's the middle again. My middle.
I don't think it's, oh wait,
Like
oh,
this
winter.
is-
Okay, there we go.
This is
Right.
a guy that listened too much to Journey.
And so this is 3/4. So
Take a
Okay.
while to get for some of you to get that joke.
Okay, so,
as long as you're in the rectangle,
okay,
it
well,
doesn't matter where you are.
can you use any of those to reach your answer? Like you could use the right or the left or the weird star.
Uh-huh.
Okay, well,
Yeah,
I
that's
like,
what it's saying. Yeah.
okay, well, I like the right.
I
That,
do too.
I'm not using this weird star thing. I'm not doing that.
Okay.
And then you get to that one problem in the textbook that says
You have to.
use definition 4.
So Let's see. We're gonna use definition 2 because the book likes the right side,
I do too.
right?
I
Because
do.
that's the
like
most.
that I-
it's the easiest. So let's do one example with numbers now. So how about this? We're gonna use definition 2 since we wrote it down. We are gonna try to figure out the expression for the area underneath the curve as a limit of f of x. And here's our function. Our function is not x squared anymore. It is ln of x over x.
So
Let you guys write it down.
People who don't.
Let's go with it here. So I got
know more about that than me.
function is ln over x, and we're gonna try to get the graph that goes from 3 to 10. So let's see. First things first is let's do this. What is our formula for the width of each of our rectangles?
E minus A over N.
Perfecto by me. Let's go with it here though. So it is going to be b over a over n. In this case, it is 10 minus 3 over n, because that's how many iterations we have, right? So 7 over n is the width of each of our rectangles. So then the question is, what's my x sub I value?
Three.
So let's see. Formula is
Wait, are we doing the left or right?
we're doing the right because definition 2. Yeah.
So
So a
3
plus
plus
I
plus 2, 7 over N.
You glitching?
Oh.
That way too far.
Yes.
You're close here. I'm going to go with I, right? Because the iteration.
Oh, wow.
So it'd be I times 7 over n. And if you want to write just a little bit more nicer, how about 3 plus, you can do 7i over n. You can do 7 over ni. Any one of those would work just fine. We good? Okay, so let's put it together now. So let's go into the explicit sum formula.
So we're defining x to the I and A plus I minus delta N. Or 3. Is that in the
Right.
original definition of 2?
For 2, yep.
That's the original.
Oh, that makes
Uh-huh.
more sense. Now I can do this problem. Okay. I was very confused on how we got there.
All right.
Not very confused. I was just very confused when looking at the problem initially, when
Mhm.
they were using only abstract stuff. It's better to explain things in
Chronological
Solid.
order.
solid, like for number 17, which we have in the homework. It was just, and then I was looking at the examples in the book and like, that's too many letters, man. I need numbers. I need
So definition 2, the area is the limit as n goes to infinity for the right side.
Something tells me Mickey Mouse is running from the mall. Like, think of where, sorry. Just think of where the Mickey Mouse clubhouse is located and the amount of contraptions in them.
Let's go. So limit as x goes to infinity of, let's see, I is equal to 1 to n. And now the question is, what is our function?
Mickey Mouse fought and
F of X.
I think it was what? It was ln, wasn't it?
X
ln.
over
Perfect. So here in this case, it's going to be, let me do this here. Let me do it like this here. Let me write it as abstractly first, and then we'll plug in the function. That'd probably be best. So f of x sub I, right? Because that is our formula for definition 2. So limit as n goes to infinity stays. I is equal to 1 to n stays. But our function is ln of, what's my x sub I term?
Where did Ellen come from?
From our
3 plus
problem.
7.
Our problem is f of x is equal to ln of x over x. So it's ln of 3 plus 7i over n over the x value itself, which is 3 plus 7i over n, multiplied by what?
7i over 7.
Just 7 over n, right? Because that's my width of each one. So there it is, guys. That is the right endpoint, right? Or the right side of the rectangle explicit formula for the function of ln of x over x going from 3 to 10.
And we just leave it at that.
And we leave it at that. We're not
Oh,
we're
we
not
don't.
calculating it.
Oh,
No, just
I mean,
What's the next test?
How did we get the
It's not talking.
Yeah.
Why would you say that when?
A
you
little
have
bit
a
after
thought?
spring break here, yeah.
Are we gonna have,
Because of-
are we gonna have like a presentation, at the end of the year?
Yeah,
Okay.
absolutely. Okay, guys, we're good there. So
I do, but yeah.
we got the forward way. Let's do the backwards way now. So let's go like this here. So determine what region we're talking about. Yep. So back to the,
No.
and this one's a little bit interesting because when you go backwards, it is,
I'm very confused on how we got the 3 plus 7i over 3 plus. So x apparently equals 3 plus 7i over n.
X sub I does.
X
And the
over
reason
I.
why it does is because we go back over here. So remember for definition 2, the formula for the X sub I value is A.
No, I
plus
don't. That's
I.
what my problem is.
So because we're taking the right-hand side of it, we always already start off where we're starting, which is A, right? And because we're taking the right side of our rectangles, we already 1 over each time.
Might just give that a star and plop it down. So
Okay.
A plus he built it up.
Of A plus I delta X. That's an I.
I see now.
All right, let's go backwards here. So determine what region we're talking about if this was the explicit formula. So now going backwards here.
Actually,
Oh gosh, that's not healthy.
I know. I don't even know.
That's not healthy, Esther.
You haven't properly
I stayed up
adjusted
late
to a
doing
horrible sleep
homework,
schedule.
so. Well, and senior project live.
Oh,
Okay, yeah, what are
what
you
time
gonna
is
do
it?
in college, Lucy?
Like,
I'm totally
not
fine with
really,
staying
let's
up
go to
late.
10.
Notice the
Certain
contrast
things.
here. Really thin. Me, I got bed early too. 11.
Good lord.
Hey, if the Lord didn't want me to use 20 out of the 24 hours a day, he would have made only 20.
But like,
There
Friday.
we go.
No.
What can I say?
All right, let's go with it here. So what does this mean?
That is a great question.
So first things first, we got to determine the fact that this, it could be different answers
Yeah.
depending on what the function is. We good?
Mhm.
Just want to get that across. So let's go with it first. So let's do 2. We're actually going to create 2 different functions. So it depends what it is.
Okay, you can stop that anytime, thank you.
So first things first, notice that we have this little connection between 2n
You and your brain.
and 2in.
Can we just go with like this, a literal
Pause.
break?
So we know that we have a width of 2. We good?
Oh.
So now the question is, where is it starting? Is it starting at 0 or is it starting at 5?
5.
It could start at 0. It could start at 5, depending what the function is. We good? So let's go with it here first. So Weston says it's starting at 5. Let's break it up. Let's do this here. I think I can break it up like this. We'll do one function here, one function here. We good?
You have to do it.
It's a H.
Yeah, because you can have multiple representations here. Let's see.
I'm
So-
just curious how you got 0 and 5. I mean, I see the 5.
So let's go back to this one here. So remember our width is here, right? And then this guy, we know we're going to have n divisions, right? So now the question is, how do we get this 2? How you get a 2 over here? It's going to be the subtraction of 2 numbers, right? And so isn't 2 minus 0 a 2?
Mhm.
So that means my starting or my end value was 2. And my begin value was, are we good there? Does that make sense there?
Mhm.
Usually probably like 8 minus or 7 minus 5.
Perfect. Okay, so the other possibility was you have to have a width of 2, right? You know you have division by n. But my starting point is this 5. So it could have been 5 was the starting point and we were actually at 7. So the question is, what is my area? Where does my area start for this problem? Is it from 5 to 7? And that's what I'm trying to find? Or is it from 0 to 2? And that's what I'm trying to find. We good? So both of them are technically correct based upon what the function says. So let's do this here.
Why did we get 7?
As we put this together, we'll get it after we get this here. So real quick here, look at this function right here. What does this function look like? What does this function do? Like if I were to write f of x is, what would you guys say?
Is the X.
Perfect. Yep, this function is x to the 10th power. That is my function. We good there? And if that's the case,
Would it be xi to the 10th or not?
No,
Oh, okay.
because that's the summation, is next to the original.
all right, my function is here, right? If that's my function, that means my beginning value was 5. So there's my a value. Are we good there? That's my a value.
Second question. Why a 7 and 5 in particular?
Uh-huh. Because remember our xi value, right? For definition 2 always starts off with a. And a
But it
is
could be 4 and 2
hey,
or
we'll get there in just a bit here.
Oh,
Uh-huh.
no.
Yep. So that's my begin. Right? And this is how I get to the next pieces, right? So my a value is my begin value, and eventually I get to b, right? So if this is my function right here, right? My a value is
5.
5. My b value is 7. Are we good there?
Yeah, no. What? A equals 5.
Because I have to have a width of 2, right? The difference between where I begin and where I end.
I just think it's funny that Eli is shooting on his pin cabinet with
No,
like
I'm not.
a cigar or a cigarette. Sorry.
I'm not chewing on it, which is you don't chew on a cigar.
Sweet gosh, Weston, don't you know how to smoke a cigar? Come on.
So talk to me if we were good here. Are we good here? So my a value, my begin value is 5. My function is this.
Very good. Good. I'm just slow in saying yes.
My begin value is 5, and then I have to have a width of 2 because I'm going to go 2 away from 5. And the only way I can get 2 away from 5 is that my in value is 7. So what is the area I'm trying to find?
The area from 2 to 7 of x to 10.
Area of
5 to 7.
f of x,
My
right?
fault.
Yeah,
You
10
can write that out. It says it, and
x to the 10 from from x equals to 5 to x equals 10. Are we good there? Oh, sorry, 7. So the area of f of x squared for x equals 5 to x equals 7.
How do we know
From?
that 5 is A?
What is that?
From,
From.
I know it says right there that it's 5, but how do we know that particular thing is 5?
because
Is it
of,
what-
sure.
Okay, there's a formula here which I
Because
don't
of-
have that tells me exactly why, but
Sure. So
A.
let's go back to
Yep,
definition.
I have it. Xi equals A plus I delta
So
X.
for definition 2, this is your begin value, right? This is where you began. Right? Okay. Next, are we good there?
Good thing I wrote it down.
That's always.
This makes
Or-
sense. Yes.
We
And that
use
is
the book to-
that is one answer. Yep.
Oh, okay, that's okay.
What? Where's the answer? There's a lot of things there, but which one is the answer?
Answer is area of
you said with
f of x to the 10th power, because that's our function, x to the 10th power. And from x equals 5 to x equals 7.
Yes,
From-
Okay.
Listen,
Don't you agree?
there's a difference between appeasement and compromise.
So this is
What?
just one
There
function.
was no
Okay?
term that it couldn't just pencil. I just got it back.
So now the question is this: is there another function I can use? Is 5 plus xi over n to the 10th power?
U.S. close to starting World War III over a freaking tree in North Korea. Sorry.
Is there another function? Maybe this was another function that we were not thinking about, and I'm going to give it to you. How about this? How about if the function was 5 plus x to the 10th?
Whoa.
Right. That itself was the function itself. So now the question is, what's my a value? What's my b value?
That's when you get 0 and 2.
So the only way I can start this, right? If that was part of my function already, that means these guys are directly connected to each other, right? There's a difference of 2 and there's no separation between the two. So now we start off at 0 and we're going up to 2. Good there. So the function is the one that actually kind of makes this ambiguous, right? We kind of don't know what the function is, but as long as you set the function, then the rest should flow out of it here. Can we do a different one? Yes. Maybe the function was 3 plus x, right? That would have been making things different too. But those usually are going to be the two that are back in the book.
Okay, so it would be k plus x raised to the 10th. For any number k, positive or whole number.
Yeah, not going to make this thing super abstract. Yes, that's actually that would work. Okay, are we good there? Does that make sense? So what you choose for the function is going to determine what your in values are.
You have to write out area.
Area, I'll write it without chicken scratch now. Area of, technically should be the curve under, but I'm kind of being lazy. The curve under f of x being 5 plus x to the 10th from x equals 0 to x equals 2 this time.
So what we should do is we should write out 2 of them, or can we just write
No,
out
just write
a
one.
general
Yeah.
one, like k, and then from
Oh yeah, no, you don't need to do that one. You don't need to do the k
that's
value.
like the most correct.
True.
I know that.
What, you got bad news?
That's the only.
No, but they still
I have bad news.
Okay. All right, you guys talk to me. Are we good with that? I know that was super abstract here.
So it's only 1.
So you only need one, yes. And then if your function matches with the function with Bob, right, then you can determine what your A and B are, right? And if it doesn't, then it's going to be off just a bit.
Okay.
Okay. You guys talk to me here. Let's see. We got 20 minutes left. I guess we can start 5-2. So let me end
Could we
this guy.
do one more example and might that example problem be 17 from 5.1?
17 from 5.1. Do you know what the problem is?
Yes, I do. F of x equals
Well, don't we
four
do
root
electric?
or
You can always do
quad
that.
root x, a root with 4
Yes,
x,
we can.
and then 1 is,
Not with that much.
or x is greater than equal to 1 and less than equal to 16. So
Does your volleyball coach know?
Let's see. Can we handle that next time? Maybe.
Yeah,
Yeah, let's do that. Let's do
I
that
won't
next
be here
episode.
Friday, by the way.
Oh, gotcha.
Just point that
Okay.
I'm
Well,
so done.
He's not gonna be here Friday.
Yeah.
Oh.
So we're gonna do the homework, but so then we'll handle it on Monday then.
Got
maybe. So let me jump to 5-2 just because we probably should get through as much of the material as possible. Okay. So we're gonna be about halfway through 5.2. And so what we want to do is we want to get into the whole concept of the definite integral.
That thingy was
That
poorly
thingy.
thinking scared me since I was.
Okay, so 5.2, this guy's called the definite integral, which means we're going to start somewhere and we end somewhere. We good? And now that little guy here, it is actually called the integral right there. That's a symbol for integral.
Sure.
And hey, we know this one right here. It is the limit as n goes to infinity of the summation from x equals, or I is equal to 1 of n. And notice we're using the most generic formula for it, right? If we use the most generic formula, the right side and the left side, or whatever side we want, is going to fit into that formula, right?
So should we write out this formula right there?
Yeah, on top. And so A and B are called the limits of integration. A is called the lower limit. B is called the upper limit. And then f of x, the function that we're actually using, is called the integrand.
That is a great name.
Integrand. Extegrand, integrand.
Avery, do you remember this in English class? And Mr. McCullough brings up a word like that is a beautiful word.
Yes.
It's like it's a slur.
Yes.
I'm like, God dang it.
Yep.
It had a meaning.
Added
It
meaning already.
was yeah, it wasn't it was more like an intellectual
Mhm.
ish, just like an insult. I was like, God damn, now you had to go and ruin this beautiful word.
All right, then we have d of x. D of x it's called the dummy variable because I can technically put whatever I want in there, but it's usually connected to the graph usually connected to f of x.
Today is April 3rd.
1776.
So no, double second.
Yeah, that's just my late first fool's joke.
Oh,
Sorry.
okay.
Wait,
No, it's today.
yeah.
Yeah, it sucks because the 1 year it aligned. Next year they'll get April Fools at school, not us. No, the world knew it was too dangerous.
You'll get it in college.
I would have
These type of
gaslit the
seniors.
living crap out of everyone at this school. Oh my
You
gosh,
can do
there'd be
that.
propane
You
fires.
can do that, Dave.
Oh my
Okay, I'm so glad it didn't happen then.
The,
can do
the
that
amount of
when they work out.
gaslighting would compare to Kuwait in 1992.
Okay.
Sorry, there's more history jokes going.
Integrand. Integrand.
Why did I think
Grand.
Dummy variable.
So it could be anything, but no. It could be anything, but it's usually connected to the function, right?
is that like a definition or a proof? Like it's the CRM.
That is the formula for it. So,
So we're defining the.
oh, that's true.
integral
So it's
sign.
definition, yeah.
So
Integral sign is defined as that right there, which we just learned. So we're connecting a whole new notation to something we've learned already. Okay. All right, let's begin. Let's see what happens here. So generic formula is good. All right, and then we have this one's the super generic formula. We good? If you want something less, don't need to write it down, but if you want something less generic, like you actually will fill in what the function is. We good? So if this was x minus cosine of x, right? If that was my formula. I don't know why I didn't write it in here. Say my function is x minus cosine of x. So this guy will translate into this one. Are we good? So the x changes into x asterisk of I. Okay, are we good there?
Probably.
So far, so good. All right, then you have the more specific formula. Then the specific formula says, hey, I'm going to have a width of 3. Everybody good there? All right.
Is it always 3?
Nope. It could be 7, could be 4. We did 2 last time, right? And then what we do is we write in the values for those. Good there. So let me go back just through it again, just to make sure. So that is the most generic formula you can have, right? That does not say anything. It doesn't define the function for you, right? Doesn't define anything. The next iteration of it, more specific, is it defines the function. The function now is x plus cosine of x, but it doesn't tell you where you start, where you end. We're good? That's not stated yet.
Mhm.
And then if you want a little bit even less generic or maybe a specific formula, now you're saying, hey, there's a starting and end point of this stuff. And in this case, if that was the formula from before, my starting point is what? Anybody? What's my A value here technically?
K.
1.
I'm going to go with
Oh, A
0.
value.
And my B value is?
B value is back here. B value is n.
3.
3, right? Because
It
we're
could be
3
anything, couldn't it?
3 units away. Not when you define what f of x
Oh,
is, right?
okay.
F of x now is defined as
Oh,
x
okay.
minus cosine of x. Okay. Let's review these guys here before we
Yeah.
begin.
I just see a Christmas tree. Yeah, I'm just gonna leave a Christmas tree.
No, done. Are we done?
No, we're not done.
What a press.
So,
Krampus's
some
Christmas
formulas.
tree? Instead of joy and holiday cheer, it's just integrals.
Let's see if we can do one problem here. Let's see. It'll get easier, guys. It will. I promise. It's gonna be interesting. So this is just review. Remember, this is from Appendix E. Do you guys remember this formula? Whenever you have an I, if you're doing iterations of I, it's this one. If it's I squared and if it's I cubed. And then if you're summing something, right? And I think we did this one as well, right? Didn't we do this one? Summation of C is just N times C. Yeah. What you can do is you can move a multiplier out of the summation. We did this when we did limits as well here. We can move summation into addition and we can move it through subtraction. Are we good? So those are the properties there. Let's see. And then, do you guys remember this from algebra?
Pascal's triangle.
Pascal's triangle and the binomial expansion theorem. Do you guys remember this one? In order to expand binomials, let's say a plus b to the second power, the way we expand it is this becomes 1, that becomes 2, and that becomes 1. And we expand these out. And then it becomes 1, 3, 3, 1. This becomes 1, 4, 6, 4, 1. And so those are the ones that actually will need, I think we go up all the way to 5 one time on the homework. That's why I made it up to here. Okay, let's try one together before end of class here. So here it is. Can you express the following as an integral from 0 to pi of that specific question? So we're just trying to go from what we know, which is the summation formulas, into the integrand formula. And the integrand form is going to be so much more easier.
Banana pudding. Do we stand for it?
Never had it.
Yes, you should. Very good.
It's
the best pudding.
It's just better than.
Have you tried banana pudding?
Me?
No, her.
So. Then how do you know?
I think so.
Okay, this is like Tony saying, "Oh yes, I had pumpkin pie, therefore all pie sucks."
I'm gonna get you some of my grandma's.
What? Just skip.
It's so good.
All right, so it does tell us where we start, where we end, right? It says we're going to go from 0 to pi. What is the function that's sitting there?
X cubed plus X sine X.
Perfect. X cubed plus X sine X. All right, and then that is my function. And then
dx.
the dummy variable is dx. We good? So Keith, you missed the equation part here, but the equation part is A and B. This is your begin value, end value.
Okay.
And this is the new sign that we have now. It
It's the
is called
same
the
as-
integral sign.
Same as that one. Same or the difference?
Yeah, so all this stuff means this stuff by definition.
Hmm.
And so let me just go back real quick here.
Oh, okay. So it's not as bad now.
Is it like a S because S is a curve and it's from pi to 0 of a curve? Kind of looks like for me.
I don't think it's meant to be
Does
fast.
near the curve with two numbers on the other side, so it kind of looks like that is just tilted.
Ethan, here's your here's by notation definition here. So I'm saying stuff we've covered so far is giving me the same. That's my new notation. That's the old notation.
Where does the dummy variable come in? Like why do we need
Well,
it?
Oh yeah, so the dummy variable is because you do need to know what variable you're using to do the antiderivative. But it could be that you have your function in terms of x, right? But your value is in terms of z, or you have a different dimension. Or you can have x's and y's in here, but you're trying to take the derivative with respect to another variable.
Right. Got it. Bacon.
Oh my gosh, stop talking. You do this every class and it makes me hangry.
Cool,
Every
okay.
class.
All right, let's go with.
So imagine you could just have
I don't have crispy.
I like my bacon juicy and soft.
Bacon.
All right, so let's do one.
Yeah, but it changes the flavor.
No, different
Oh,
types of.
Wait, that wasn't
good
an
on
example.
milligram.
That was it. That was it. We just changed from one to the other. Right? We changed from the old definition to the new one. So now let's do it this way here. Now let's go forward. Here's my iteration. It's going from 0 to 3, I think. Is that 3 down there? Yeah, 3.
The long way. Sorry.
So we're going to go the integral from 0 to 3 of x cubed minus 6x. And let's see if we can do this in
Uncrustable
6 minutes or less.
sandwich.
So we're going to do this the other way. We just need to figure out where we start. So this is one example here from 5.2. All right. So going 0 to 3. So now I have to go backwards, right? So this is, I'm going to try to write some formula here from this. So I'm going from 0 to 3 of that function there. And let's go with it here. So the difference between that one, my width would be, what's my beginning end values? All right. We're going from 0 to 3. So therefore it's 3 minus 0. And we got ourselves 3 over n. Are we good? Next is, I like using definition 2. So this is going to be my three I over n, right? I get the 3i over here and I stick it on, sorry, I get my 3 over n over here and I stick an I next to it because I'm trying to figure out the iteration of each piece. And so that's going to be to the third power, true, was minus 6 times x itself. That was from the previous slide. I think this is very close to the one that you guys have on the homework here. So that's why I'm doing this. I think it's like an x squared over here. Okay, so now let's put this all together. So going backwards, right, on the definition for 2, this is going to be now the limit as n goes to infinity of the sum of I from 1 to n of this function called 3i over n to the third power minus 6 3i over n times my delta x. Everybody okay, 3 over n. So that's what I got to do right there. And we have done this already before. So we just kind of came full circle here. We've made some new notation called the integral notation, but this we've done before. We did this with x to the second power. Remember how we did it? We got a 1/3 using the right side and 1/3 using the left side. So nothing new here. So let's jam with solving this. So what I got to do first, let's expand stuff out. So the 3n, let me just kind of do like this here, move things out. So I got to work with the i's. My function has i's in it, but my 3 over n doesn't have an I in it, right? So I can move that all the way out of my summation piece. It has to be before my limit, but I can move it out of the summation. So now let's do this here. And tell me if I'm going too fast. I just want to finish up before class ends so we can have one piece there. So if this is the case, I'm going to move my summation into each of those pieces here. So 3 times 3 times 3 is 27. Is that right? Move the summation to here. I can move the 6 out because that doesn't, there's no need for the 6 to stay in my summation. It's x to the I of 3i over n. In fact, I could have even moved the 3 out if I wanted to, right? So what I'm trying to figure out, I'm trying to isolate the I value as much as possible. We good? Because I is the one that's I'm iterating.
Oh, and you do the limits through the limits through, and you distribute the limit for the.
Yeah, let's see here. Let's see. I'm just trying to finish it as much as possible here. So the summation of 27 I to the third over I n third, I can move the 27 out. I can move the n out because the whole point is having the iteration of i's, right? Over here, I can move the 3 out and the n out. So this would be 18 over n My only iteration here is just I. Oof, getting close to time here, guys. Let's see. Can you guys help me out here? What is the explicit formula for the summation of I from 1 to n of I cubed?
N plus one parentheses, divided by two squared.
Perfect. Yes. So we're going to change these guys into explicit formulas, and notice the i's will disappear. We'll only have n's, right? And then this one is just n plus 1 over 2, right? So let's write the explicit formulas now for these summations. Crazy stuff, guys. Crazy stuff. And then we'll figure out the short way of doing it, because this is the long way. Okay. Tell me if you guys are good for me to go on to the next slide.
Yeah.
Okay, just to finish up before time here. So here it is. Now these guys are the explicit formulas now. So 27 over n cubed, and then n plus 1 all over 2 to the second power. Now this one was, oh, cool. It hides right there over there. That is to the, we still have the n going to infinity, right? Okay, so our job really is just to simplify this as much as possible right here. So I'm going to just kind of keep on writing. We good? So over n, 27. Yep, these guys are going to be long. I think there's only 2 of these in the homework here, though. So this is n cubed, n plus 1 cubed, oh, sorry, squared over 4. This is going to be 18. Oh, you know what I can do is I can probably cancel one of those n's eventually.
I looked away at the long one.
So I just squared this right here. I kept everything else the same. So now what can I do? I can probably cancel stuff out. So I'm thinking I have n cubed here and n squared there. I can cancel those out. Let's see. I can cancel the 18 and the 2, make a 9, and the n's will cancel completely. That's cool. So I got myself that. Sorry, guys. We're going to go like 1 minute over just a little bit here.
That's fine.
All right, and I will.
Times 1 time. Well, 5x4 and over 4 and
Perfect. Yeah, so we got some fractions to deal with here. Let's see, and then I have it recorded here. So if you need to go back to it, right, I'll send the link to the recording to Sophie as well as everybody else.
Well, I could go back. However, I would prefer not to. I'll just have it in my notes.
Okay. All right, we've got a little bit of time still to do here. So common denominator, right? That's what we need here as well as expanding this n plus 1 to the second power. So limit n squared plus 2n plus 1 over 4n. And then I can distribute the 9 to this side.
Oh,
Don't worry about it.
Oh, no, let's stop here then. Let's stop here.
no, we don't want to be in the
No.
You guys
I'm missing
should
most
be
of
in the
the images.
pictures.
So we're basically done. We can just like, all that is a simplification. So we're just basically done.
Yes, but
I don't
simplifying it
understand
correctly.
anything upside down except for
I do,
the
I do,
three
I
over
do.
lines
I
there
agree.
every single time. That's all I know.
Just keep clicking, Mr. On, dude. Just keep clicking. Click, 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 click.
Wesley, I may be fast, not no.
Go ahead.
Okay.
Are we gonna have to use Logan all the
Go Power Rangers.
No, because we have derivatives here.
What syndrome?
One more slide, guys.
Oh,
Go fast.
Sonic.
Okay, so
invented in
quick raise of
physics.
hands. How many are
Chris Chan.
at least understanding what we're doing? Okay, how many like just writing it down just to write it down? Okay, just to make sure.
A bit of both.
I'm understanding. I'm not writing it down. When I write it down, I wouldn't understand. So I'm not writing it down.
Oh, I'll be reading this later. Does it say an LN or 81? Is that 81 or
You
LN?
and me have the
81.
opposite.
81
Yeah,
n to the second over 4
You
n
write
to the
it down
second.
and then understand later. I get it now. And
If I read it through enough, I'll eventually understand it.
One
Is that
more
62
slide here. One more slide.
n
We're done.
that's
Four and squared.
the video?
I'll watch the video.
Okay, so this is a lot of arithmetic, guys. Just a whole bunch of arithmetic here. So we expanded out to our n+1 squared right here. We multiply the 27 at each piece here, right? And then we're going to multiply the 3 over n into this fraction and then also into each of these pieces. Now the question is, can I simplify this?
Yeah.
Yeah, n squared and n squared are going to cancel each other out, right?
81.
And
And over here and n over here is going to cancel themselves out. So then we were left with this right here. So let's do this here. N's actually, I even
But if you
so
just-
the n's are
yes.
gone, is that right?
Mhm.
So this is going to be 81 over 4, true?
Yes.
This is n over here, but there's an extra n on the bottom, right?
Mhm.
As n goes to infinity, isn't this going to go to 0 right here?
Yeah.
And then over here, that's going to go to 0 because n gets huge.
that's gonna
Right
be-
here, these n's cancel. I'm only left with a 27. We good?
that's
And then
gonna be
here,
0.
that's going to go to 0. So
24 minus 7. No, 81 over
You
4
would.
minus 27.
perfect. That's it right there. So 20.2 and a quarter minus 27 makes a
over n.
negative
The 27 over n also goes to infinity, correct?
6.75. Say again?
The 27 over n goes to infinity,
Yeah.
correct? Or is 0, correct?
Yeah.
The n over n, those cancel out, so it'll just be.
Yeah. So on your homework for 5.2, yes, there's gonna be those on Friday. Where it's just a long problem. And then we'll see if we can shorten it out.
Sounds good.
You are welcome. See you guys.
Thank you, Mr. Hunter.
You are welcome. You're welcome, guys. You guys enjoy the rest of your week and weekend. See you Monday. Yeah, I'm sorry. I had to just finish up real quick. Go, Eli. Go,
Yep.
and I'll wait. Sorry about that.
Did- Is he able to come do this really quick?
Yeah, absolutely. Yeah, yeah.
I'm literally just.
We were just kind of debating whether to do it or not.
I can't promise it's the last picture we'll need, but I think it might be.
Yeah, go.